Good morning students, plus 2 physics lesson 3 magnetism. So in the previous class we had discussed some basic about magnet. So what are the applications of magnet, then angle of inclination, declination. So now, basic properties of magnet. So first one, magnetic dipole moment. So consider a bar magnet. So O is a geometric center of the bar magnet. From O to the one end of the magnet. So that is the length L. So 2L is a magnetic length. So actually a geometric length is there. Geometric length is the actual length of the magnet. Here 2L is the magnetic length of the magnet. So magnetic length is always lesser than the actual length, that is geometric length. So what is a magnetic dipole moment? It's a product of pole strength and magnetic length. So its P is equal to Q times D. So D is a length, that is magnetic length. So D is a length, D is 2L. So D acts from south to north. So in magnitude wise, its P is equal to 2 times QL. So Q is a magnetic charge or pole strength, that is strength of the pole. So unit of magnetic dipole moment is ampere meter square. So magnetic dipole moment is product of pole strength and magnetic length, that is Pm, it's a vector, it's Q times D. Then, so what is my magnetic field? So space around the magnet, the field is magnetic field. Here magnetic field at a point is defined as a force experienced by the bar magnet by unit pole strength. So in electric field we have seen force experienced by the unit charge. Here force experienced with the bar magnet of unit pole strength. So E is equal to F by Q. Here B is equal to F by Q. Here it's charge, here it is pole. So it's a space around the magnet or region around the magnet. We feel the magnetic field. So how we feel? Using another magnet, bring the magnet towards the region, we feel attractive force or repulsive force, or some other magnetic material just inside the region. We feel if it is attractive, suddenly it goes and sticks with the north pole or south pole of the magnet. So what is the unit? It's Newton ampere power minus 1 meter power minus 1. The next, types of magnet. So there are two types of magnet, natural magnet and artificial magnet. So iron, cobalt, nickel are magnetic natural magnets. Then their strength is very weak, their shape is irregular. Coming to the artificial side, so they are made by us, depend upon our need and strength. So if it is so strong compared to natural magnet, so the size is regular shape. If it is in rectangular, cylindrical, that is artificial magnet. And finally, polar lights. So in northern hemisphere and southern hemisphere, people see that is aurora borealis and aurora australis. That is, people live in Arctic and Antarctic regions at high altitudes, they see the polar lights. That is due to some interaction between the gaseous particles present in the Earth atmosphere with the highly charged particles released from the sun's atmosphere through the solar wind. So just see. So this is Earth. So this is northern hemisphere, southern hemisphere. So this is a Earth atmosphere. So Earth atmosphere. So in Earth atmosphere, some gaseous particles present. So in northern hemisphere and southern hemisphere. So from the sun, so sun rays, so charged particles coming from the sun during the solar wind. So that reaches, there is a collision between the charged particles from the sun and gaseous particles in the Earth atmosphere. Due to the collision, we get some colored light. It emits light. The emitted light is in pale yellowish green, means so the ionized oxygen interacts. If it is blue purplish red, means ionized nitrogen. So that's all. If it is ionized oxygen interacts, there is a presence of ionized oxygen during the interaction, pale yellowish green color will get. If it is ionized nitrogen molecule, blue or purplish red we will see. So in this class we have discussed basic properties, magnetic dipole moment and magnetic field. So magnetic dipole moment is a product of pole strength and magnetic length. Then magnetic field is force experienced by a bar magnet of unit pole strength. Then types of magnet, natural and artificial. Then finally, how polar lights, so what is the process going on behind the polar lights. Okay students.